All right, let's say if you have the integral of an absolute value, then what should you do for that? So when you have an integral of an absolute value, you cannot take the integral directly because we don't have the derivative at the sharp corner when you have an absolute function. So when what happened that we can do, we're gonna have to find out where's the sharp corner. So we're gonna set x minus 1 equals 0. So you're gonna have x equal 1. This is where your absolute function have the sharp corner. So you draw that. So at x equal 1, you have the sharp corner, and you will have the absolute function will look like this. Okay, so if you draw that in the decimal to confirm, you're gonna see something like this. Okay, so 1 is where you have a sharp corner, and you want to find the area under this absolute value function from -2 to 3. Okay, so we're gonna have to find the area of this. Okay, all right, so you can use geometry to find that, or you can use the definite integral. So in order to do that definite integral, we need to break it into two different integral. So you can separate from the sharp corner. So the sharp corner here is 1. So I will be able to break it into -2 to 1. And because the line from -2 to 1 is actually the decreasing line. So you should have the slope is negative. So we will have negative x minus 1 dx. Okay, and then plus integral from 1 to 3 x minus 1 dx. And then now we're going to take the antiderivative. So you can distribute the negative and make that become integral from -2 to 1, negative x plus 1 dx. And then we have 1 to 3 x minus 1 dx. Now let's take the antiderivative of negative x. Negative is coefficient, so stay the same. And antiderivative of x to the power 1, the power increase, so x to the power 2 over 2, plus antiderivative of a constant is constant times x, so it's going to be 1 times x, which is x, and we take it from -2 to 1. Similarly to the second integral, the antiderivative of x to the power 1 is power 2 over 2, minus constant times x, and we take it from 1 to 3. Now we're putting the value, we have -1/2 plus 1 minus, put this in, we have -4 over 2 minus 2 plus 9 over 2 minus 3 minus 1/2 minus x minus 1. Okay, and then we simplify. -1/2 plus 1 is 1/2 minus 4 divided 2 is 2. So it's going to be -4 plus 9/2 minus 3 is 9/2 minus 6/2. So it's going to be 3/2. So 3/2, and then minus 1/2 minus 1 is -1/2 minus -1/2. Okay, and then we're gonna have 1/2 plus 4 plus 3/2 plus 1/2. And simplify that, we have 5 over 2 plus 4, and which is 11, I mean not 11, right? 8 plus 5, which is 13 over 2. Okay, and you can check that with your calculator if you have one. So you're gonna have 5/2 plus 4, and that will give you 13 over 2. Okay, so this is how you find the integral where you have an absolute value involved. Or you can find the area directly from using the geometry, right? Let's do that with the geometry. So I have the base here from -2 to 1 is 3, right? 1 minus -2 is 3. So the base is 3. How about the height? When my x is -2, I'm putting -2 in here. So I will have -2 minus 1, which is -3, and that become +3. So the height here is 3. So mean this is 3. So 3 times 3. So area on the left side is 1/2. 3 times 3, which is 9/2. Okay. And how about the second area? So this from here. So 1 to 3 is 2. And when I putting 3 into this, is 3 minus 1 is 2, right? 3 minus 1 is 2. So the height here is actually 2. I actually draw a little bit taller. So it should be shorter. Okay. So it's actually 2. So the height is 2. So we have the area 2 on the right side will be 1/2. 2 times 2, which is 2. So 9 over 2 per 2, which is 13 over 2. Okay, so it's the same thing. This is your geometry. This is your definite integral.